The objectives of spinning are: A. Reduction in weight of drawing sliver into a thin fibrous strand by drafting or attenuation of the fiber mass. B. Twisting of the thin fibrous strand emerging out of the drafting zone to form a yarn with acceptable strength. C. Winding of the yarn onto a suitable package. The conventional spinning frame used in jute mills have three types of drafting zones: slip draft system, apron draft system, V-grouped roller draft system. This is a slip draft spinning frame with a pitch of 4¼ inch and with 100 to 110 spindles. Its share is around 80% of the total spinning frames used in the jute industry. This slip draft spinning frame is used to spin conventional Hessian, warp weft and shacking warp yarn. All qualities with grease ranging from 7 to 16 pounds per spindle can be spun in this machine, which can achieve maximum flyer speed of 4,250 rpm with backstar flyer and 4,000 rpm with two-legged flyer. The reach, that is the distance between the retaining rollers and drawing rollers, is 9½ to 10 inch. We are observing the motion of a slip draft spinning frame. The starting handle is released by pushing the trigger arm. With downward movement of starting handle, the jockey pulley tightens the Lennox belt by lever and weight arrangement. Motion is transmitted from motor to machine pulley and on to the cylinder. Warp crowns of two consecutive flyers get dry from the cylinder. Cylinder and warp crowns are connected by a cotton or synthetic tape called listing, which is tensioned by tension pulleys and dead weight. And also to drawing and retaining rollers through gearing. From the other end of the retaining roller, the motion is transmitted to mid-draft roller and to the hard cam. Also, the motion is transmitted for slow traverse of drawing roller. We are observing the function of a slip draft spinning frame. This drafting system is most convenient for jute yarn spinning. The sliver path is not straight and hence the length of sliver path is more than the reach. The twist is imparted by rotation of a two-legged flyer and the yarn is wound on a package called bobbin. We are observing the drafting zone and its function in a slip draft spinning frame. The name slip draft has been coined because the long fibers slip through the mid-draft rollers while moving from retaining to drawing rollers. The sliver enters the drafting zone through a pair of retaining pressing rollers with lever arrangement having hanging weight of 4 pounds. Both rollers have flutes. The pressure on the sliver is adjustable by shifting the weight on the lever. Next is an adjustable breastplate. This keeps the sliver tight during the movement of sliver through the drafting zone. This ensures controlled delivery of short and long fibers through the mid-draft rollers. Next is a deep-fluted mid-draft roller and a deep-fluted dumbbell-shaped self-weighted idler roller. There are 3 conductors for the right alignment of the sliver passage. The central recess part of the idler roller ensures easy movement of long fibers without break or obstruction, while exerting restraining actions on the movements of the short fibers as we are observing. Finally, there are drawing pressing rollers. We are observing the twisting of the fiber bundle and formation of a twist triangle. Finally, there are drawing pressing rollers. The drawing pressing roller is loaded by a coil spring. The pressure is adjustable by a nut. The pressure should be adjusted after buffing of rubber cord of the drawing pressing roller. Draft can be altered by changing the draft pinion. Higher draft pinion means lower draft and vice versa. Draft constant divided by draft pinion gives draft. We are now observing the twisting and winding zone with Baxter flyer. Nowadays, Baxter flyer is mostly used instead of two-legged flyer. The legs of two-legged flyer expand during rotation. Baxter flyer has ensured higher flyer speed without any expansion. In today's spinning machines with Baxter flyers, both the bobbin size and the lift have been increased. As a result, the yarn content per bobbin has been increased. The Baxter flyer has a warp cap and warp crown with a central hole through which the yarn passes. The yarn passes through an inner tube of the flyer and then under a specially designed long notch of the flyer body and subsequently to the bobbin through the flyer eye. At each point where the yarn comes under the contact with the flyer body, there are porcelain guides to avoid abrasion between aluminum part of the flyer and yarn. Due to passage of yarn through inside surface of the backstar flyer, the ballooning of yarn is avoided. Let us now see the twisting action with two-legged flyer. In case of two-legged flyer, the yarn after passing through warp cap and warp crown hole is wrapped round a leg of the flyer and then passes to the bobbin through a flyer eye called NKI. Due to the direct contact of jute yarn and steel, the steel body gets cuts. Due to centrifugal force, the legs of the flyer expand during its rotation, and also the yarn expands due to ballooning effect. Let us now understand twisting and winding of yarn. One rotation of the flyer inserts one twist to the yarn. If the flyer rotates at 4000 rpm, it will insert 4000 turns to the length of delivered yarn during 1 minute. If it is 1000 inches, then twist per inch, that is TPI, is 4. Twist can be altered by changing the twist pinion. Higher twist pinion means lower twist and vice versa. Twist constant divided by twist pinion gives twist per inch. A bobbin carrier is placed on the dead spindle fixed on the bobbin rail. At the back surface of bobbin carrier, there are 4 felt bobs which are pivoted with adjustable clips. The positions of the felt bobs can be adjusted to change the average spinning tension. Position A gives lowest tension and hence used for spinning finer yarns. While position C gives highest tension and hence meant for coarser yarns. At the back of the bobbin, there are 8 holes, 2 of which get easily secured on 2 pins located on the bobbin carrier. A bobbin is placed on the bobbin carrier and rotates with the yarn drag. Winding takes place due to the difference of speed between flyer and bobbin. Let us now see the piecing of yarn. During piecing, the weight is lifted manually to allow sliver entry into the drafting field. Piecing is done by taking yarn from the running bobbin or from an external bobbin. The yarn is then fed over the drawing pressing roller. It gets overlapped and twisted with the drafted fiber mass. Thus the new yarn formation continues. The grist of the piecing portion is just the double of that of the yarn being spun. Let us now see the function of the mechanical stop motion. This stop motion is activated by a detector assembly. The short lever notch is connected with a yarn filler. The filler is pushed by the yarn while spinning continues and the notch gets out of contact of the mid-draft lever group. The short lever is attached to a long lever. A stopper weight and a nipper assembly are attached to the other end of the long lever. When the yarn breaks, the short lever notch comes in contact with moving mid-draft roller and is pulled. With this action, the long lever gets pushed and the weight falls, while the nipper detaches the drawing pressing roller and prevents sliver entry into the drafting field. During piecing, the weight is lifted manually to allow sliver entry into the drafting field, and when piecing is done, short lever notch gets out of contact of mid-draft roller. Two levers called T-levers are actuated by a small handle near the starting handle. When the handle is down, T-levers drop down and the stop motion gets activated. At the start, T-levers are not actuated and thus the stop motion is also not activated. After a little building of bobbin, the T-levers are actuated and so the stop motion starts working. We are now observing the basic mechanism behind the bobbin building motion. Bobbin building motion, that is up and down movements of bobbin rail, is actuated by a hard cam through levers, pulley and chain. With one complete rotation of cam movement, one complete up and down movement of bobbin rail occurs. During building, bobbin may have various defects. These defects can be rectified by adjusting turnbuckle. These defects can be rectified by shifting traversing lever position. Yarn coil spacing in bobbin can be changed by changing the pinion at the other end of the retaining roller. Now let us see the doffing mechanism. There are two sets of bobbin rails. One is working and the other is spare. When the bobbin is nearly full and bobbin rail is at the top position, the spare bobbin rail with empty bobbins is shifted inside by a foot wheel. There is a dog lever which prevents further movement of spare bobbin rail. When the bobbin is full, by engaging hand wheel gearing, by pushing a hand lever clutch, the building motion is detached by disengaging a plunger knob with the help of a hand wheel. The downward movement of bobbin rail is actuated. The full bobbin rail is brought down by rotating hand wheel. When the rail comes in contact with the shifting rail, the dog lever is released. Now full bobbin rail is shifted outwards for doffing by foot wheel and the empty bobbin rail is lifted to the spinning position by hand wheel. Now the plunger knob is released with the help of hand wheel to activate the building motion. The hand wheel gearing is seen getting disengaged by the hand lever. The full bobbin rail is brought down by rotating hand wheel. Now full bobbin rail is shifted outwards for doffing by foot wheel and the empty bobbin rail is lifted to the spinning position by hand wheel. Now Full bobbins are doffed and placed on spiked cart for winding. This is a slip draft spinning frame with a pitch of 4 and 3/4 inch. This frame has 96 spindles and can spin 7 to 32 pound per spindle yarn. This machine with a reach of 10 inch has Baxter flyers. Nowadays, sacking weft yarn is being spun in this machine at a flyer speed of 3200 rpm or more using 3 drawing system with more percentage of long jute. Apart from sacking weight, sail yarn of heavier counts, that is 16 pound and above, are also spun in this machine. The drafting zone contains retaining and pressing rollers, breastplate, mid-draft roller with self-weighted idler roller, and drawing with drawing pressing rollers. In this machine also, draft and twist can be changed with the help of draft and twist pinions respectively. It has also simple mechanical stop motion. This is apron draft spinning frame with a pitch of 4 1/4 inch and with 110 spindles normally. Its share is only 7% of the total spinning frame in the jute industry. This machine is used to spin yarn in the count range of 4.8 to 12 pound per spindle. 90 to 100 pound per spindle sliver is used. This machine with a reach of 10.5 inch has Baxter flyers. Maximum flyer speed is 4750 rpm.